You are given an n by n integer matrix. Rotate it 90 degrees clockwise in place, modify the same matrix. Do not use a second n by n matrix to hold the final picture. Example 1 is 3 by 3. After we start from a copy of the before grid, spin it 90 degrees clockwise, then replace it with the upright final layout so the numbers read normally. Top left and top right both care about the finished corner slots. A curved nudge shows where one wants to slide, while the other corner has nowhere to hide yet. That tension is why we follow a fixed recipe instead of random pushes. Transpose is a flip across the main diagonal. The 3 off-diagonal pairs, 2 with 4, 3 with 7, 6 with 8, can trade in parallel while 1, 5, and 9 stay on the diagonal. Mirror left and right columns across the middle. The center column stays put while the outer columns trade places row by row, finishing the clockwise quarter-turn layout. Transpose in place by visiting only slots strictly above the main diagonal, each paired with its mirror below that diagonal. If we walked the full matrix we would swap everything twice and land back where we started. Next mirror every row left to right, 2 pointers start at the far ends and swap inward along the row. That horizontal flip turns the transpose into the finished clockwise quarter turn. N is the side length of the square matrix. Time is O of n squared in the worst case. The transpose pass touches each off-diagonal pair once, and mirroring each row scans every cell a constant number of times. Extra space is O of 1, we only keep a few indices and swap in place without allocating another n by n array. Function rotate clockwise updates the n by north matrix in place for a 90-degree clockwise turn. The outer I loop drives the transpose pass over the board. The inner J loop only visits slots strictly above the main diagonal. Swap that off-diagonal pair with its reflection across the diagonal. The R loop walks each row for the left to right mirror pass. Pointer L starts at the left column of the current row. Pointer R starts at the right column of the current row. While L stays strictly left of R we keep swapping inward. Swap the 2 entries in row R at columns L and R. Advance L 1 step to the right. Move R 1 step to the left.